All right, page 9. Let's get this one started. See, I didn't say here we go. Okay, we have a TI, so that's good to know. Particle moves along the x-axis with a given velocity. Time is greater than or equal to 0. Position is 5 for t equals 2. So what this is saying, let's translate. The position at time of 2 is 5. So that's good to know. Okay. Part A, write a polynomial expression for the position of the particle at any time. Polynomial, this is huge. If I'm doing that, that means I cannot use an integral, I cannot use a derivative. So what we have to do, if we're writing an expression for position, I need to integrate velocity. So I'm actually doing this by hand. So x of t equals, when I integrate, I get 3t cubed over 3, so they cancel, minus 2t squared over 2, the 2's cancel, minus t plus c. Now this is close. That is a polynomial, but I cannot leave a plus c in there. I actually have to find it. Luckily, they gave me some given information, so I can sub that in. 5 equals 2 to the third minus 2 squared minus 2 plus c. 5 equals 8 minus 4 minus 2 plus c. 8 minus 4 is 4, minus 2 is 3, so c equals, I didn't do that right, 2, so I've got 3 as the final answer. 4 minus 2 is 2. When I subtract 2 from 5, I get 3. Okay, so now when I sub that in, x of t is t cubed minus t squared minus t plus 3. Here's the weird thing. I don't like that they said that, but they said expression. So I'm just going to say, boom, there's my expression for position. Okay? Part B, for what values of time from 0 to 3 is the particle's instantaneous velocity the same as its average velocity? Two different ways of doing this. Instantaneous velocity, that means your derivative, that means velocity. And think about this. Instantaneous velocity, that means I want the velocity at a specific instant. If I want the velocity at time 10, let's say for example, then I would plug 10 into velocity and find the velocity at that instant. So instantaneous velocity, that means I want velocity. It is the derivative of position. Now if I want average velocity, that would be slope of the secant using position. So that's where that previous answer comes into play. So x of 3 minus x of 0 over 3 minus 0. There's my interval. Velocity equation is 3t squared minus 2t minus 1 equals, if I do all this, I get 5 as an answer. Now, your other option, if you recall, instantaneous velocity is velocity. I want that to be the same, equal to the average velocity. If I want average velocity, then I integrate velocity over my interval and I divide upper limit minus lower limit. So now I have options here because I can do this on my calculator. I also have the position function, so I can do slope of the secant if I want to. I now have options, and if you put this on your calculator, so now I already have velocity on my calculator. This is my velocity equation that they gave me. If I integrate this equation from 0 to 3, there it goes, I get 15. 15 divided by 3, if I look at this, the integral is equal to 15, divide by 3, you still get 5, which is exactly what you have for your slope of the secant. So no matter what, you end up with this equation right here, instantaneous equal to average. Now, what I do to solve this, I put velocity as y1 on my calculator, and I put 5 as y2 on my calculator, and you want to find the point of intersection. Final answer, t equals 1.786. That's your final answer. Part C, find the total distance traveled. Total distance from 0 to 3, that's going to be the integral from 0 to 3 of the absolute value of velocity. So when I do that on here, I actually have the absolute value on my calculator. I read the question ahead. So now I'm going to turn that equation on. I turned the first one off. So now I'm going to graph that, and I'll integrate that from 0 to 3. Notice everything is above the x-axis because it's absolute value. If I integrate, oh, it's still graphing. Second trace, option 7, 0 to 3. So now it's going to integrate over that interval. And I've got 17 as an answer. Now, find the displacement from 0 to 2. The displacement is just the integral of velocity from 0 to 2. So if I want to do that, I'm going to go back to my calculator. I'm going to turn the absolute value off, turn velocity back on, and then when I go to my graph, so now it's graphing velocity, I want to integrate velocity from 0 to 2. Second trace, option 7, 0, 2, let's see, and I get an answer of 2, so this is 2. Now, find the position at 2. If I set this up, that's a new position, x of 2 equals x of 0, where did you start, plus what was your displacement from 0 to 2. Okay, now looking at this, does that look familiar? Because you don't actually have to do any of this. The position at 2 is 5. That was your given information at the beginning of the problem. So this is just checking to see if you're following along. If you actually do this whole problem, though, you will get 5. Okay, so it will work out. You will get the same answer. Hopefully that helps a little bit and that makes a little more sense.